Hello, this luckiest maths teacher in the world. So you're probably wondering, what do you need to know for your test? Well, I'm going to go through everything you need to know for the first test. So first thing you need to know is you need to know order of operations, so BIDMAS, and this includes negative numbers. So you are allowed calculators in your test, but I don't want you to get cocky and think, oh cool, I can just put it on my calculator, because I might still ask you questions that you can't do without a calculator. So for example, I might say that I want to do the calculation minus 7 plus 5 in brackets times 2 divided by 3. I might ask you which operation you do first. So you can't put that in your calculator. You can't get your calculator to tell you the answer to that. So you need to be able to know BIDMAS, know the order in which you do things without a calculator. So obviously in this case, the first operation I do is in the brackets. It's the addition. So you need to be able to do questions like that. You might also get a question where I say somebody says that minus 2 plus 3 times 7 equals 7. What have they done wrong? You can't get your calculator to do that. So of course in this case, what have they done wrong? Well, if you do minus 2 plus 3, you get 1 times 7 does equal 7. So what they've done wrong is they did the addition first, and they should have done the multiplication first. So the right answer, the answer they should get would be minus 2 plus 21, which is 19. And you would need to be able to articulate that in a test. So make sure you know BIDMAS and make sure you're not just relying on your calculator. If I give you a question like minus 3 times 7 plus 5, yes, you can just put that on your calculator straight away and it will give you the answer, which is minus 16. But you need to know the order of BIDMAS without a calculator, because I might ask you questions that you can't use your calculator. All right, so what else do you need to know for the test? So what you also need to know for the test is terminating and recurring decimals. So remember, a terminating decimal means the decimal point ends, and recurring means not only it goes on forever, so it never ever stops, but also that there is a pattern to it, because sometimes decimals go on forever and there's no pattern. In fact, that's what irrational numbers are. So examples of terminating decimals. So 1 over 5 has a terminating decimal because it's 0.2. One number after the decimal point and then it ends. 1 over 16 has a terminating decimal. It's 0.0625. Now there are 4 numbers after the decimal point. Now at this stage you only need to be able to use your calculator. So what I said in class was that if it has more than 5 numbers after the decimal point, assume that it is a recurring decimal. Of course it is possible. This number here is 0.215968. That's terminating because it stops. But we're not going to give you ones with really long terminating decimals. So I'm promising you that in the test, if you're asked, does a fraction have a terminating or recurring decimal, you will be able to tell very clearly by putting it on your calculator. Examples of recurring decimals. So 1 over 3 has a recurring decimal because it's 0.333. The 3's go on forever and don't stop. And there's a pattern. Each number after the decimal point is a 3, and we write this as 0.3 recurring. So 1 over 6, for example, is recurring. It's 0.16666. The 6's go on forever, so we write a dot only over the 6. Now even though there are 2 different numbers after the decimal point, it's still recurring. There is a pattern. The first number is a 1 and every number thereafter is a 6. Sometimes you'll have more than one number in the pattern. So if you were to put on your calculator the number 2 over 11, so that has a recurring decimal because it's 0.181818 and goes on forever. There's a pattern. Every odd number digit after the decimal point, so the 1st, 3rd, 5th, 7th, etc. after the decimal point is a 1, and the 2nd, 4th, 6th, 8th, etc. place after the decimal point is an 8. So we write that like this. Because the 1 and the 8 are both recurring, they both get a dot, or you can just put a dash over them, either way. So that's terminating and recurring decimals. So you also need to know irrational numbers. So what you need to know for irrational numbers is what they are, and you need to be able to tell whether or not a number is irrational. So any fraction with integers, so remember integers means whole numbers, that is always rational. So always, no exceptions, is rational. So the number 3, because I can write it as 3 over 1, is rational, not irrational. Same with any whole number. So the number 4 over 7, that's a fraction with integers, that's rational. 13 over 5, yes, it's an improper fraction, but it's still a rational number because it's a fraction where the top and bottom are integers. And if it has a terminating or occurring decimal that we just went through, then it is also rational. So terminating or occurring decimals, any numbers that you can think of with a terminating or occurring decimal, they will be rational. So 0.25 is rational because it's terminating. 0.3333 going on, which is a third, that's recurring decimals, so it's rational. So all of these are rational. So how do you know an irrational number? It doesn't have this. So an irrational number means it's none of the above. So you can't write it as a fraction with integers, nor can you write it as a terminating or recurring decimal. So most of the numbers you know of, they are rational numbers. So irrational numbers are like pi. So we looked at pi a little bit, and you'll see more of that later in the year. But anytime you take the square root of a number that's not a perfect square. So the square root of 3, because 3 is not a perfect square, that's irrational. The square root of 71, that is irrational because 71 is not a perfect square. But the square root of, say, 16, that's equal to 4, so that would be rational because 16 is a perfect square. So make sure you know perfect squares are numbers that you can multiply a number by itself to get that number. So 1 is a perfect square because it is 1 times 1. 4 is a perfect square because it's 2 times 2. 9 is a perfect square, and so on. So if I take the square root of any of these numbers, it is rational, but if I take the square root of any other number, it's irrational. So 101, not a perfect square, so the square root of 101 will be irrational. All right, now I'm going to go through what you need to know out of percentages. Okay, so firstly, you need to be able to find a percent of a quantity. So remember, I've said there are 2 steps to this. You firstly change the number, the percentage, to a fraction or a decimal, and then multiply by the quantity. So for example, 70% of 80 equals 70 over 100. So I've changed the percent to a fraction times 80. And that, just put it on your calculator, you get 56. So we need to also know one quantity as a percent of another. And you need to make sure that you don't get these mixed up. So when I find a percent of a quantity, I already know the percent. So 70% of 80, I know the percent, and it's 70 over 100. When we're finding one quantity as a percent of another, we need to switch these 2 numbers around. So for example, let's say I get 20 out of 25 in a test, and I want to make that into a percent. So the difference between this and the first one is that I don't know the percent here. So I've got to calculate the percent. So it's first quantity divided by second quantity times 100. Put that on your calculator, you get 80, the answer is a percent. So if you get 20 out of 25 in your test, you will get 80%. So make sure you know the difference between this type of calculation and this type, because people mess them up all the time. So what you also need to be able to do is percentage increase and decrease. So that's related to the first type. So you just find a percent of a quantity and then add or subtract that. So for example, if I want to increase 50 by 32%, I take 50 and I add 32% of 50. So 32 over 100 times 50 is 32% of 50. Put it in your calculator, you get 66. If I wanted to decrease, let's say I want to decrease 50 by 32%, then it'd almost be the same, except instead of adding 32% of 50, I take it away. So it'd be 50 minus 32% of 50, and that equals 34. All right? So the other thing you need to know is about profit and loss. So firstly, you need to know what these things are. So remember, profit is when the selling price, so that is how much a customer would pay for it in the store, is greater than the cost price. The cost price is how much it costs the business to buy it or make it. So for example, if you were going to buy a cologne from David Jones, the selling price is what you would pay. The cost price is what it costs David Jones to buy it from the people who made it. And of course, a loss is just the other way around. That's when the cost price is more than the selling price. So if you bought something for $100 and only sold it for $80, you've made a loss. So what you need to be able to do is you need to be able to figure out the percent profit or loss. So have I made like a 20% profit or a 15% profit or whatever? So use the formula. It's just the profit or loss. Now, it's usually over the cost price times 100, but you have to look out. It depends whether the question says find the profit or loss as a percent of the cost price or as a percent of the selling price. So you make sure that you read the question. So let's just do a quick example. So if I buy something for $240, sell for $300, what's my profit as a percentage of the cost price? So it is the amount of profit I made here is $60 over cost price, what it cost me, times 100. And that is 25%. If it was as a percentage of the selling price, it would be almost the same. I'd just do 60 over 300 times 100, and that is 20%. Okay? Now, you also need to be able to mark up and discount, but that's just an application of percentage increase or decrease. So let's do a quick example. So if we do this one here, an item normally costs $75 and is discounted by 40%, and I want to find the selling price. So discounts, they're just an application of percentage decrease. So this is exactly the same as saying, if I have $75 and decrease by 40%, how much do I have? So it's just 75 minus 40% of 75, and you can put that straight in your calculator, and you should get $45. So that's the new selling price. All right, good luck in your test. This has been the luckiest maths teacher in the world. Have a great day.